I am recording also. You will get recording mode also. Let's start with what is actually surface chemistry means. So the surface chemistry deals with the phenomena that occur at the surfaces or interfaces. What are the important features of this in this chapter? The first one is the adsorption. The next one is the catalysis. The next one is the colloids. Now, what is an interface or surface? For example, you take oil in liquid. For example, oil and water, if you mix, what will happen? As we know, oil floats on water. So here, oil and water are immiscible substances. Therefore, upper layer will be oily phase and lower layer will be water phase or aqueous phase. Now, the interface is the separating layer between these two phases. The interface is generally few molecules thick. Then, suppose if you take alcohol in water, what will happen? In alcohol in water, the both intermix each other and forms homogeneous mixture. If they form the homogeneous mixture, what will happen? There won't be any interface. Now, what about gaseous mixture? As we know, gases always intermix spontaneously and forms the true solutions. You remember the solution chapter. What is a solution means? Forms a homogeneous mixture. A solution is a homogeneous mixture. That means it is a uniform phase we observe and there won't be any interface. Since the gases intermix spontaneously, therefore we can say that there is no interface between the gases. The next one is, what is adsorption means? Adsorption is accumulation of molecular species at the surface rather than bulk of solid or liquid, we can call. Now, here two things you have to learn. To remember in solutions, we have the major proportion solvent, minor proportion solute. Similarly, here also we observe adsorbate, the minor proportion, the molecular species or substance which concentrates or accumulates at the surface. That we call it as adsorbate. So what is adsorbent? Adsorbent is the material on which the surface, on which the molecules are adsorbed. So look at adsorbent is just like solvent, the major one. So adsorbent is the material on the surface of which the adsorption takes place. So adsorbate is synonymous to solute, adsorbent is synonymous to solvent. The solute and solvent we are going to get. Here similarly we have adsorbate and adsorbent. Now what is desorption? Here desorption is the process of removing an adsorbed substance from a surface on which it is adsorbed. Simply adsorption, desorption are antonyms. We can say that adsorption is accumulation, desorption is removal of the substance. Now what is occlusion? Occlusion is a special term that is particularly meant for the adsorption of gases on metal surfaces. If you remember, nickel is used as a catalyst for conversion of oils into fats. Here nickel adsorbs the hydrogen gas. So therefore we can say adsorption of hydrogen gas on nickel is termed as occlusion. Now as we know, adsorption is essentially a surface phenomena. Therefore more the surface area, more the extent of adsorption we are going to observe. Now let us see some applications regarding adsorption in action. The first one is adsorption of gases. For example, if you take a balloon, some balloon, it has some mixture of air, that is a gas, a mixture of gases. Put some charcoal in that balloon. What will happen? This mixture of gases adsorbed by the charcoal such that the balloon volume contracts. This is the adsorption of the gases. The next one is adsorption of dyes. What is this adsorption of dyes? Suppose if you take here, let's have a YouTube video regarding adsorption of dyes. So here, let's have a look at there. Here I am having a methylene blue dye. So in this methylene blue dye, what I am doing is I am mixing activated charcoal, which is an adsorbent. What will happen after some time? Let's have a look at that. It does not have any dye, but here we are mixing the dye. What will happen after some time? Look there, it forms a clear solution. So what is happening here? Yes, have a look at that. So in the adsorption of action phenomena, adsorption of dyes is an important application. Here the dyes like methylene blue are adsorbed by charcoal. Not only that, adsorption of coloring waste is another application. For example, if you take molasses, actually it is brown in color. This molasses is passed through a bed of animal charcoal such that we will get a clear solution of sugar. Generally we know the sugar is very clear, very crystal clear we can say. Here actually the molasses is brown in color with impurities. These impurities also removed by the phenomena of adsorption. The next one is adsorption of moisture. For example, if you see some delivery packets, we observe some crystals of silica in that. A small pouch of silica gel will be there inside. From Amazon delivery or whatever if you see. So here the moisture content is absorbed by the silica gel. So these are the adsorptions in action. Another one is adsorption chromatography, where we have seen this. In general organic chemistry, in practical organic chemistry, you have seen we have to purify the substances by using a chromatography method. There are two types of chromatography. One is adsorption chromatography. The next one is partition chromatography. To remember. So in adsorption chromatography, the substances are separated or purified. These applications we will see at the end also. These all are present in NCERT only. The next one is what is the difference between adsorption and absorption? Look at the pronunciation is same, friends. AD, adsorption, AB, absorption. So here, looking same, there is a difference. B, absorption, D, adsorption. Let's have a look at, sorry, I am getting messages from the team members because they are not able to do something. In adsorption, the substance is concentrated only at the surface and does not penetrate to the surface to the bulk of the adsorbent. But what about in absorption? In absorption, the substance is uniformly distributed throughout the bulk of the solid. Look at the diagrammatic approach. In adsorption, what will happen? Here the particles are accumulated on the surface only. Look at the arrows that I am showing. But in absorption, the particles are going inside also. Now let us see a special term called sorption. What is this sorption? In the sorption phenomena, both absorption as well as adsorption takes place. But how it is different from adsorption or absorption? In sorption, what will happen? On the surface, there are more molecules compared to the bulk, or on the surface, there are less molecules compared to the bulk. In the additional material, we have given a positive sorption and negative sorption. So, what is positive sorption means? Positive sorption means on the surface, the molecules are more. What is negative sorption? On the surface, the molecules are less compared to the bulk. So, in absorption, there is uniform concentration all over, but in adsorption, on the surface there is accumulation, but in sorption, we observe there is the molecules go inside, also they are adsorbed, but there is a marked difference between the concentration of on surface as well as inside. The next one is why adsorption takes place. Yes, let's have a look at this diagram. As we know, if you take the surface molecules and bulk molecules, inside molecules. So here the inside molecules experience an uniform attractive force. Look at there. Here the forces are balanced. But on surface molecules, what will happen? Here on the upper periphery, actually we don't observe any attractive force, but there is attractive force here. Therefore, there will be a net inward pull. This net inward pull is also known as surface tension. If you remember, that is force for unit length. We have seen in fluid mechanics of physics. So this net inward pull, what does it do? It creates certain energy that is called surface energy. So this surface energy actually make this molecule tensed. To reduce this energy, what will happen? The surface molecule tend to adsorb the foreign substances. Look at that. So here adsorption arises due to the fact that the surface particles of the adsorbent are not in the same environment as particles inside the bulk. Inside the adsorbent, all the forces acting between the particles are mutually balanced. Here, the particles are mutually balanced. But on the surface, the particles are not surrounded by atoms or molecules of their kind. Therefore, what will happen? There is an unbalanced force or residual attractive force. To reduce the residual attractive force, the adsorption takes place. Now, let's have a brief look about the thermodynamics. Now, if you remember the second law of thermodynamics, what a process is spontaneous. When a process is spontaneous. If you remember, when there is a decrease in free energy, the process becomes spontaneous. So, when the free energy decreases, here the free energy depends on two factors. One is enthalpy factor, another one is entropy factor. So here, if the Gibbs free energy is negative, the process is considered to be spontaneous. If the Gibbs free energy is positive, the process is considered to be non-spontaneous. Now, what happened to the change in enthalpy and change in entropy during adsorption? Now, let us talk about enthalpy. As I told you, the surface molecules experiences some residual force. There is some surface energy on a surface molecule. So they are tensed. They are unstable, we can say. So during adsorption, what will happen? There is always decrease in the residual force. That means there is decrease in the surface energy. Then where this surface energy goes, this surface energy goes or appears in the form of heat. That means during adsorption, what will happen? The enthalpy decreases. During adsorption, enthalpy decreases. What will happen to entropy? Look at there. Suppose, if you remember regarding entropy, what is entropy? Entropy is degree of randomness or degree of freedom. Generally, gas molecules have high randomness. So the gas molecules, if they are trapped on the surface, what will happen? They reduce their randomness. Their movement is restricted. Therefore, what will happen? Obviously, the entropy of the gas has been reduced. Therefore, during adsorption, the entropy decreases. Enthalpy decreases as well as entropy decreases. Here, all of you please note down an exception. Please note down an exception. Please note down an exception. During adsorption, enthalpy decreases, entropy also decreases. Write down an exception. I hope all of you are writing down. Let me see. Are you writing down? Are you writing down, please? Yes. So, generally, adsorption is exothermic process. Generally, adsorption is exothermic process. And during adsorption, entropy decreases. This is right statement. If they have asked it, you can go for it. But is this a right statement for all the adsorptions? No. There is an exception. The exception is adsorption of hydrogen gas on glass surface. The exception is adsorption of hydrogen gas on glass surface. What will happen here? What will happen here? Here, when hydrogen gas is adsorbed, hydrogen molecule split into hydrogen atoms. When hydrogen gas is adsorbed on glass surface, hydrogen molecule split into hydrogen atoms. As we know, when one gas molecule split into atoms, entropy increases. Look at what we discussed. Adsorption. During adsorption, entropy decreases, but adsorption of hydrogen gas, entropy increases. Exception. Now, what about enthalpy? What about enthalpy? During adsorption, enthalpy decreases, that we know. But in case of hydrogen gas, when it is adsorbed on glass, hydrogen molecules split into atoms. That means we are breaking the bond. Therefore, enthalpy increases. Adsorption of hydrogen gas, exactly opposite terms we are going to get. Exactly opposite phenomena we are going to observe. Enthalpy increases, entropy increases. Both are increased in case of hydrogen adsorption on glass. The change in enthalpy decreases in adsorption. Change in entropy also decreases in adsorption, right statements, but not in all cases. In the adsorption of hydrogen gas on glass, enthalpy increases, entropy also increases, just exactly opposite. Then, I hope all of you have written. Then, what will happen? Do the adsorption is spontaneous? Yes. Look there. The adsorption is a spontaneous phenomena. Why? As we know, enthalpy decreases the negative value, entropy increases the positive value. General statement, if you go for in adsorption, enthalpy decreases, entropy also decreases. What about this T delta S? Minus T delta S will become positive. When the delta G become negative, the negative value dominates over positive value. When the negative value dominates over positive value, the net value will become negative. Therefore, during adsorption, what exactly happens is that delta H negative value is sufficiently high than the positive minus T delta S value. Therefore, an absorption is a spontaneous process. Then, what will happen when the process is taking place? As we know, adsorption, when it is spontaneous, it goes in forward direction. Then the delta H becomes less and less negative. Delta H becomes less and less negative. Ultimately, the delta H becomes equal to T delta S value at a position called equilibrium position. If you remember, in chemical equilibrium, we have seen at chemical equilibrium, delta G is 0. There is no change in Gibbs free energy. Why? Because the delta H magnitude of exactly equal to T delta S, such that at equilibrium, the delta G becomes 0. I think we know this. We have learned in chemical equilibrium. Now let's discuss the types of adsorptions. There are two types of adsorptions. One is the first one, physiosorption. What is physiosorption, friends? In physiosorption, the accumulation of molecules takes place on the surface through the weakest forces. As we know, what are weakest forces? They are van der Waals forces. So in physiosorption, there are weakest forces and they are not specific. What about chemisorption? In chemisorption, the gas molecules held by the surface through a chemical bonding. That's why this is called chemisorption. In physiosorption, the attractive forces are not actually, they are weak, but in chemisorption, the attractive forces are strong. So the chemical bonds, what type of chemical bonds they are in chemisorption? They are either covalent or ionic in nature, that we know it. Now, what about physiosorption? Physiosorption is not that specific. As we know, van der Waals forces are present in all type of substances. For example, I am clapping my hands. They are non-specific. Between these two hands, there are van der Waals forces. But in case of chemisorption, I told you there must be a formation of covalent bond. To form the covalent bond, we need to give a spark. For example, you have a gas cylinder at your home and methane gas is there or butane gas is there and oxygen is there in the environment. You mix the oxygen and methane, Will the reaction takes place? No. We need to give a spark. Then only the reaction takes place. That spark is actually called activation energy. So chemisorption needs some activation because we need to form the bonds. So chemisorption involves a high energy of activation, and therefore it is also referred as activated adsorption. It is also referred as activated adsorption. The next one is, do the chemisorption and physiosorption takes place simultaneously or not? Let's have a look at. Yes, sometimes these two processes occur simultaneously, and it is not easy to ascertain the type of adsorption. Obviously, it is very difficult because they are microscopic things, somewhat difficult to identify what type of adsorption takes place. Generally, we can say one point: physical adsorption takes place under mild or low temperature conditions, but chemisorption takes place when the temperature is increased. Why? As I told you, physical adsorption does not need any activation. Even at low temperature, it takes place. But chemisorption needs high temperature. We have to increase the temperature. Let's have an example. There are many examples. For example, you say Haber's process. Haber's process you can take. Here the example is given as Chemistry-Sanderson process. What is that? Hydrogenation of oils into liquids, where nickel is used as the catalyst. Here, at low temperature conditions, nickel physically adsorbs the hydrogen. When you heat it, what will happen? The hydrogen gas converts into hydrogen atoms. These hydrogen atoms are attracted by nickel by a bond, whatever that is, maybe covalent bond or polar covalent bond. So at high temperature, chemisorption takes place. At low temperature, physiosorption takes place. Similarly, if you take manufacture of ammonia from Haber's process, take nitrogen on iron surface. Initially, nitrogen physically adsorbs on iron surface. Upon heating, iron nitride will be formed. A chemical bond is formed. Therefore, chemisorption takes place. Let's have a detailed discussion of physiosorption. In physiosorption, what will happen? As I told you, in physiosorption, the attractive forces are very weak. Therefore, there is no specificity. That means physiosorption takes place on any type of surface. Any type of surface. Since van der Waals forces are universal. What about the next point, that is nature of adsorbate? Let's have a look at, if you remember, in states of matter, let's go back. In states of matter, you know the ease of liquefaction. If attractive forces are more in the gas, then a gas can be easily liquefied. Similarly, if the gas can be easily liquefied, then it can be easily adsorbed on the surface. Then how do we know about ease of liquefaction? If you remember, the phenomena called critical temperature. What is critical temperature? It is the temperature above which a gas cannot be liquefied. That means higher the critical temperature, it is easier the way to, or easier the gas to be liquefied. What is the formula of critical temperature? If you remember, the critical temperature is 8A by 27 RB. If you remember, what is A here? A is intermolecular force. Then what is B? The size of the molecule. Now here, higher the critical temperature means higher the attractive force. Higher the attractive force means easier the rate of adsorption. Now let's have a look at the examples. Generally, in NEET exam, they will give the critical temperature data. They will give critical temperature of two gases or more than two. Here I have given two gases. Critical temperature of sulfur dioxide is given as 630 Kelvin, and critical temperature of hydrogen gas is given as 33 Kelvin, which will be easily adsorbed. The problem is very easy. Since sulfur dioxide has high critical temperature, we can say it can be easily liquefied. Obviously, it can be easily adsorbed. Therefore, the rate of adsorption will become SO2 greater than H2. So, simply, the rate of adsorption is exactly opposite trend of critical temperature. Rate of adsorption is exactly same trend of critical temperature. So, higher the critical temperature, higher the attractive forces, higher the rate of adsorption. So, they will give the sequence of critical temperature. You have to identify the sequence of rate of adsorption of particular gases. Now, let us see the characteristics of physiosorption continuity. Now, let us see the reversibility. As we know, van der Waals forces are very weak. They can be broken easily, they can be formed easily. Therefore, physical adsorption is generally reversible in nature. This is an equilibrium process. As we know, enthalpy is negative. So, more gas is adsorbed. Here, regarding pressure also if you go for. So, here, when you take a solid is adsorbed on gas, we have to compress it. So, the more gas is adsorbed when pressure is increased. Now, at the same time, when you remove the pressure, the gas will be dissolved. That means, look at the physical adsorption is generally reversible. If you increase the pressure, more adsorption takes place. If you decrease the pressure, less adsorption takes place. In chemical equilibrium also we have seen, here when solid gas is adsorbed, then what will happen? Number of gas molecules is less in this direction. If you compress it, the forward reaction takes place. Now, what will happen when you further increase the temperature? In case of Physiosorption, there is a possibility. Increase in pressure. First, when hydrogen gas is adsorbed on nickel, one layer of hydrogen is adsorbed on the nickel. Now, further if you increase, what will happen? Further hydrogen gas is adsorbed. Now, how the adsorption takes place? Just have a look at. First, there is nickel surface, then hydrogen gas is adsorbed. One layer is completed. Now, you are increasing the pressure. Then one more hydrogen molecule may come. Now, how it is possible, sir? Yes. Between nickel hydrogen, there is van der Waals force. Between the hydrogen and hydrogen also, there is van der Waals force. Therefore, we can say maybe that force is different. The value may be different, or the extent is different. The first layer is strongly bind. The next layer may not be strongly bind, but layer will be formed. Therefore, in case of Physiosorption, there is a formation of multi-molecular layers. Kamal raising his hand. What's the issue? Right, no problem. Let's continue. So here, as I told you, Physiosorption is reversible. When you increase the pressure, rate of Physiosorption is more. When you decrease the pressure, rate of Physiosorption is less. Now let us see what will happen regarding temperature. So, since the adsorption process is exothermic, let us apply Le-Chatelier's principle. Then we can understand it a better way. What is Le-Chatelier's principle, friends? Suppose, as you remember, in chemical equilibrium, increase in pressure favors less number of gas molecules and decrease in pressure favors more number of gas molecules. Therefore, if we adsorb, what will happen? More gas will be, if you increase the pressure, what will happen? More gas will be adsorbed. If you decrease the pressure, what will happen? Less gas will be adsorbed. Now, if you remember the Le-Chatelier's principle, an exothermic reaction is favored by decreasing the temperature. As you remember, if you decrease the temperature, Physiosorption is taking place. Now, if you increase the temperature, what will happen in case of exothermic reaction? Backward reaction takes place. If you remember, in exothermic reaction, heat is evolved. Now you are increasing the temperature means the reaction shifts in backward direction. Therefore, as we know, adsorption is exothermic, almost 90%. Exception, forget about that exception now. Since the adsorption is exothermic, the physical adsorption occurs readily at low temperature. Now when you increase the temperature, what will happen? The physical adsorption decreases. Now let us see the characteristics of Physiosorption. The first one is continuity of the characteristics of Physiosorption. The next one is surface area of adsorption. As we know, adsorption is essentially a surface phenomena. What will happen, friends? More the surface area, more the rate of adsorption. More the surface area, more the rate of adsorption. For example, if you take nickel powder and finely divided powder and porous substance. For example, for nickel blocks you take it, a coarse powder, and finely divided powder you take it, which will adsorb more. Obviously, the finely divided one. If you remember, as the number of particles, as the particles actually, as the coarseness is decreasing, that means the fineness is increasing, then surface area will be more. To remember, so blocks of nickel, powder of nickel, fine powder of nickel. which will have more surface area? Obviously, the fine powder will have more surface area because small particles and more particles are there. Surface area is increased. If you do not understand, once again, let's take a cube. A cube has surface area A square units. It will have 6 surfaces. A cube will have 6 surfaces. 6A square is the surface area which is formed. Now this cube is divided into 8 equal cubes. Then the surface area rapidly increases. We can say exponentially increases. Each individual has less surface area, but total, cumulatively, if you take more surface areas will form. So we can say that smaller the particle, cumulativeness will be more, such that we get the more surface area. Now let us see what about the enthalpy value of the adsorption. In case of physiosorption, the attractive forces are very less, quite low. Therefore, obviously, the enthalpy of adsorption also low. It is between, the figure also important, please note it down. It is between 20 to 40 kilojoule per mole. 20 to 40 kilojoule per mole. In physiosorption, the magnitude of enthalpy is just 20 to 40 kilojoule per mole. Why? Because the attractive forces are weak forces. Now look at, they have given magnitude here. Actual value is minus 20 to minus 40. Here this is the magnitude. In the options they will give clearly, be careful. Sometimes if they don't give options, only magnitude is given, no problem. You can go for 20 to 40. Now let's discuss the Chemisorption. Till now we have seen Physiosorption. Now let us see what are the characteristics of Chemisorption. In Chemisorption, as if you remember, Physiosorption is non-specific. Why? Because the forces of attraction are only weak. The weak van der Waals forces. But in case of Chemisorption, the specificity is very high because a chemical bond must be formed. When the chemical bond is formed between adsorbent and adsorbate, then it will become highly specific. For example, they have given an illustration there. Look at it. Oxygen is adsorbed on metals by virtue of oxide formation. Hydrogen is adsorbed by transitional metal due to hydride formation. So, oxygen adsorption value or oxygen adsorption dynamics are different from hydrogen adsorption dynamics. For example, nickel easily adsorbed on hydrogen is easily adsorbed on nickel. It may not be same for oxygen. The extent might be different. So therefore, since a chemical bond is formed, adsorption is highly specific in nature. Now let us see irreversibility. As we know, the Chemisorption is non-specific. The forces of attraction are very weak. Therefore, we can break the bonds easily. We can make the bonds easily. We can break the force easily, make the force easily. Therefore, Physiosorption can be reversible. But what about Chemisorption? In Chemisorption, a chemical bond will be formed. Therefore, usually it is irreversible in nature. What is the meaning of this? For example, a nickel is adsorbed, hydrogen is adsorbed on nickel. Nickel, hydrogen. Nickel hydride bond has been formed as a layer. Then the next hydrogen as a second layer, how can it come? Because it is already forming a bond. Nickel, hydrogen, there is a bond between them. The next atom, another layer, hydrogen, cannot form bond with the next hydrogen. Maybe it may go Physiosorption, but not the Chemisorption. So Chemisorption is always irreversible in nature because once a chemical bond is formed, then it is very difficult to break. If you break it further, the deformation of surface also may take place. Therefore, Chemisorption, we can say that it is irreversible in nature. Now let's have a look at effect of temperature. We'll have a detailed discussion also. As I told earlier, if you remember, in Physiosorption, when you increase the temperature, the attractive forces are weakened, the van der Waals forces will be broken. Therefore, what will happen? If you increase the temperature, rate of Physiosorption will be reduced. Now, what about Chemisorption? If you remember, earlier I told you to spark, to how to give a spark, to fire, to get the fire from the LPG cylinder and the oxygen gas present in the environment, we have to give a spark. Similarly, to form a chemical bond in Chemisorption, they need some activation energy. To get this activation energy, we have to heat. Therefore, chemisorption generally increases with increase in temperature. So, physiosorption of a gas may take place at low temperature, but when you increase the temperature, the chemisorption starts. Therefore, we can say that if we increase the temperature until it reaches the equilibrium, the rate of chemisorption increases. The next one about surface area. As usual, like physical adsorption, the chemisorption also increases with increase in surface area. Generally, high pressure is also favorable for chemisorption. That is when a gas is involved. Since a chemical bond is formed, chemisorption takes place as a single layer even at high pressure. If you remember, a physiosorption takes place in more than one layer. Nickel, hydrogen, hydrogen, hydrogen. Because the van der Waals forces are non-specific. But in case of chemisorption, nickel hydride bond will be formed. After that, the next hydrogen cannot form the bond. Therefore, chemisorption is generally a single layer even at high pressure. Now, enthalpy of adsorption. This is very much important. Let's have a look at it. In chemisorption, a chemical bond is formed. A chemical bond is formed. Therefore, obviously, high enthalpy of adsorption we are going to observe. It is 80 to 240. That is 20 to 40, but this is 80 to 240. The value, magnitude is 80 kilojoules to 240 kilojoules, but if they ask the value with sign minus 82 to minus 240 kilojoules. The enthalpy of chemisorption is from 80 to 240. Physiosorption is from 20 to 40. Now let's have a brief look between the differences of physiosorption and chemisorption. This is directly from NCERT I have extracted. If you write these differences, you will get 3 marks or 5 marks, whatever in the NCERT board examination also. Let's have a look at the differences between physiosorption and chemisorption. As we discussed earlier, physiosorption arises due to weak van der Waals forces, but chemisorption takes place due to a chemical bond formation. Physiosorption is not specific in nature because van der Waals forces are formed between any type of substances, but chemisorption is highly specific in nature because a nickel hydrogen forms nickel hydride, nickel oxide forms nickel oxide. Therefore, 2 different types of chemical compounds are formed during chemisorption. Physiosorption is reversible in nature, but chemisorption is irreversible in nature. Physiosorption depends on the nature of the gas, and easily liquefiable gases are adsorbed readily. Chemisorption also depends on nature of gas. The gases which react with the metal, they easily form the chemisorption. Now, enthalpy of adsorption is low in case of physiosorption as the attractive forces are very weak. Therefore, the enthalpy of adsorption is between 20 to 40 kilojoules only. But in case of chemisorption, the enthalpy of adsorption is very high. That is from 82 to 240 kilojoules per mole. Physiosorption takes place generally at less temperature. It decreases with increase in temperature, but chemisorption takes place at a high temperature as it needs the activation energy. Physiosorption does not need any activation energy, but high activation energy is needed sometimes in chemisorption. Physiosorption obviously depends on surface area. It increases with an increase in surface area. Chemisorption also depends on surface area. It also increases with increase in surface area. Physiosorption results in formation of more than one layer. It is a multimolecular one, but chemisorption is unimolecular one since a chemical bond is formed. So these 20 slides or the 19 slides are the today's lecture. We have taken just a half an hour. Anyway, no problem. Let us have an exercise. What are the problems that we have to do for this today? Thing is that students, one day there will be chemistry and botany. Next day there will be physics and zoology. So it is like that. That means one day totally you have to dedicate for 2 chapters. It will be like this. The schedule may change. So till now, today we have discussed up to what is actually adsorption means, what is actually surface chemistry, what is the difference between adsorption, absorption. So these are the titles that we have discussed today. What is surface chemistry we have seen. What is surface? The definition of adsorption we have seen. And the different definitions here we have seen. Look there. What is adsorption? What is adsorbate? What is adsorbent? What is desorption? What is occlusion? What are the applications? Detailed applications we will see at last. What is the difference between absorption, adsorption, and also sorption? Then why adsorption takes place? We have seen. Now why? What is actually the phenomena behind the spontaneity, the criteria of spontaneity? Now what happened to enthalpy, change in adsorption, entropy, change in adsorption? Then we discussed an exception also. The next, adsorption is spontaneous. Next, 2 types of adsorption. This is very much important. Physical adsorption and chemical adsorption. What are characteristics of chemical physiosorption? Detailed discussion we have done. Lack of specificity, nature of adsorbent. As we know, easily liquefiable gases are easily adsorbed on physiosorption. Reversibility. Surface area, how it depends. Enthalpy of adsorption. Then chemisorption characteristics. It is highly specific. Irreversibility and its effect of temperature. Surface area, effect of pressure, as well as enthalpy of adsorption and the differences. So these are the things that we have done till now. In NCERT, what are the things, what up to what we have discussed? Once again I am showing you. All the points, whatever covered in NCERT only I have made as the PowerPoints. In NCERT, an introduction part is there, you just have a look at. Same thing. So in adsorption in action, they have given examples. The adsorption of gases. The next, adsorption of a dye, methylene blue. And removal of waste material from sugar. And air becomes dry in presence of silica gel. These are the adsorption in action, detailed discussion they have mentioned. What is desorption they have given. Distinction between adsorption and absorption they have given. And the mechanism, thermodynamics behind adsorption they have given. All the points I have summarized already. The next one is types of adsorption, physiosorption and chemisorption. There is characteristics they have mentioned here. And then the summary. That means up to here 5.13 we have discussed today. So you have to work on up to 5.13 in NCERT. So if you go through the PowerPoints, that is actually summary of the NCERT only. Please note down up to here we have to work today in NCERT. The additional material also has same points but as bullet points. Some people like to read as paragraphs. Some people like to read as bullet points. It's up to you. In this additional material, they have given one point. If you look at positive and negative adsorption. Actually, that is positive and negative sorption. Positive sorption, negative sorption. Some people like to positive sorption, negative sorption. Please note down in additional material we have got that is positive sorption and negative sorption. So up to here, the pressure of the gas, up to here we have discussed and the differences between physical adsorption and chemical adsorption. Adsorption isotherms in the next class we will see. So this is the additional material. this additional material also, at last we have some exercises. So look at there, in additional material, what are the exercises that you have to do after studying NCERT as well as my PowerPoints? The conceptual bits. Here they have given the conceptual bits, adsorption they have given. I think better I will write on paper and then I will post in the group. So these are the problems that you have to do in the additional materials. I will write the numbers in all the exercises. So today you have to complete the additional material exercises as well as exercises present in this. Almost all of them are theory only. So by the evening or by the within 1 hour, whatever, I will share the number of questions that how to do for the phenomena of adsorption or up to today's class. So our plan is to complete the phenomena of adsorption in 2 classes, and 3rd class there will be some important problems, and then 4th class will start the catalysis. 4th class will start the catalysis. So the plan is in 6 classes we will complete adsorption as well as the catalysis. In 6 classes we will complete the colloids. So after 6 classes or 5 classes, whatever, there may be a weekend test. We will have a weekend test not on this Saturday, might be there is next to next Saturday. That means not on this Saturday, next to next Saturday. So this is a 30 minutes class of adsorption. I will continue. I would like to continue, but however, this is first day, so we don't want to trouble you much. Therefore, half an hour class, we just go through the things, and I will identify the types of or the number of questions that you have to do. I will post within 1 hour or 1.5 hours. That's all, friends. I am stopping sharing now. If there are any query, you can message me, or you can directly message me in the WhatsApp. Better directly message me in the WhatsApp, not in the group, because others may get the disturbance. Suppose if the doubt is useful for all of them, I will post in the common group. If there is any other issue, you can talk, or I'm just unmute. I think if I unmute everyone will may talk. So if there is any issue, please raise your hand. I will unmute one by one. Anything you need to discuss, just raise your hand. Whatever regarding any issues in the clarity or whatever it may be. Just as a feedback also, if you want to give, please raise your hand. 5 minutes. Speed is okay or not? The speed. Generally, I am very much fast. That is, everyone says that. But this speed is okay or not okay? Just message me or raise your hand. The PowerPoints are visible clearly. The PowerPoints are visible. Then just thumbs up. Enough. Okay. Thing is that you don't need to write or anything. Extra material we don't provide. You don't need actually. So in this surface chemistry chapter, there are only 3 types of problems. Those 3 types of problems also we will mention. I think it clearly will explain. So you don't need to worry about it. The PowerPoints are clear. Okay, done. Any other suggestion? If you want to talk also, you can talk, no problem. You can edit the names. You can edit the names. There are some names also there. Try to get the technology first. I have to know the names. Archit is visible, his name is visible like that. Sometimes we need to interact also, if possible. If possible only, if time permits only. Right. I think this will be the end of the session. So I am closing it, and this chapter is already recorded. You will get, I think soon I will post in the group as the recorded lecture. Some people maybe miss it, you can go through it. I think the PowerPoints are sufficient. If you do not understand it, you can message me. Clear? That's all, friends. Have a nice evening.